Welcome back. In last class we studied just entered into module 1b. In that one we studied properties of soil and this indexes what all comes in this one. And properties of soil, there are two types of soil. There are two types of properties: index properties and engineering properties. Okay. Now coming to the first property of index properties is the water content. This is the first property. You already know the definition of water content. What is water content? Explained in the previous section. That is, water content is the ratio of mass of the water to the mass of the solids. If this is a three-phase diagram, in this one water is also there and air is also there. If you take a mass of this, mass of water, and if you take the mass of the solids, this is the mass of solids, and the ratio of these two, mass of water to the mass of solids. Even you can measure in terms of weight also. Weight of water to the weight of solids is defined as water content. This is the ratio of mass or weight of water present in the soil to its mass or weight of solids expressed in percentage. This, if you multiply into 100, then you will be expressing that in terms of percentage. Okay. This water content, say for example, when you take a moist soil at your hand, then how much water is there inside this moist soil? To determine that, we have methods. The first one is a oven dry method, and the second one is a Pythonometer method. Third one is a alcoholic method. Fourth, sand bath method. Fifth, calcium carbide method. Next, torsion balance method. These all methods are there. The method recommended by Indian standard is, in Indian standard we recommend only one type of method, that is the oven dry method. This is a standard and even accurate method of determining water content present in the soil. Here it is discussed both oven dry method and Pythonometer method for determination of water content. This you consider it as a homework, that how alcoholic method is used to determine the water content, how sand replacement method is used, how calcium carbonate and torsion balance methods are used to calculate the this water content present in the soil. Here I am going to explain two methods, that is a oven dry method and Pythonometer method. Now see here, oven dry method means, oven means what? That will be in a bakery also you might be seen, right? A small one setup will be there like this, and it will be having some door here. You will put your cheese or otherwise bread, samosa, something you will put here, and after that you will put in this one switch. You will on this switch, then after 5 minutes or 10 minutes there will be some hot air comes inside and it will cook this one. This is what a oven. This is what. The same way in engineering also you might be seen a big oven in a geotechnical lab. When you are performing, I think BMT lab, you come to engineering this geotechnical lab, and you might be seen this oven. A big oven will be there, and here a door, and this is the handling, and here some meter will be there, and this is connected to current. Some switchboard will be there, and this is connected to that. And this is a oven. Understood? Inside some trays you can make, and you can put the materials here. This oven is called as thermostatic oven. Thermostatic oven. And what is the thermo means? Thermo means temperature. Static means you are going to fix it for one particular temperature. Say for example, if you want 110 degrees centigrade, then fix it here 110 degree, then it will maintain 110 degree inside. That is called as thermostatic oven. Understood? Okay. Now in the oven dry method, we are going to take the soil and we are going to put inside the oven. Okay, now inside the oven. Then how much soil we need to take? For that we have a guidelines here, that is if you have a coarse grained soil, Means if the particles are very bigger like a gravel and all, then you need to take 1000 to 2000 grams, means 1 kg to 2 kg of soils you need to take and put in the oven and determine. If you have a fine gravel, then 300 to 500 grams. If you have a coarse sand, a bigger particle sand, then 200 grams. If you have a medium type of sand, then 50 grams. If you have a fine grams, then 25 grams. Silt and clay, if you are measuring the water content, 10 to 15 grams, 25 grams. These are not standard, means when you are measuring medium sand, means you should take exactly 50 gram, not like that. This is the nearer value they are giving, approximate values they are giving. If you take these many values, then only you will get a good result. If you take a coarse grained gravel, 25 gram of coarse grained gravel and put it here, then you may get a wrong readings. Therefore, some suggestions are given by experts. Okay, now you came to, in this slide you came to know that what is thermostatic oven and what is the meaning of thermostatic, and second thing you come to know that how much quantity of soil we need to take and put inside the oven. You will go to the next slide. There what you will come to know, what you will get, see. To do this experiment, what all apparatus we require? What all apparatus we require? To do this experiment, we want a small containers with lid. This is a one container with lid, and the lid is somewhat sometimes without lid also you can use, because when you put inside the oven, then the water present in the soil should evaporate. Therefore, without lid also you can use. We'll consider without lid only. In some textbook with lid they will mention, okay, no problem. This is a container we want. The container dimensions will be very small, just like your water bottle, you know. Water bottle beda. Kumkum dabbi, right? A small kumkum dabbi like a 2 centimeter height, okay, and about 3 to 4 centimeter width, okay. This is a circular container. That apparatus you want, and you want oven, thermostatic oven you want, and you want weighing balance. This is a weighing balance. Here you can weigh them, you can put it something here and weigh it, weighing balance, and what you want, over. And if you want a tray and all that, you can take. These are the apparatus you require for the water content. Then what is the procedure? Procedure is very simple. Look at here. You go to the field. This is a field. You go to the field and dig the soil. You dug the soil. Then here, from here or from here or from here, from where you want, from there you bring the soil to the laboratory. See, this is a tray and you kept this soil in the laboratory. Okay, now this is a soil. Its water content you want to determine. From this soil, you take a small portion of the soil. Here from a small portion, from here a small portion, put it in the container. This is the container. Okay, now you put that small quantity of soil here, small quantity of soil here, small quantity of soil. Before putting this one, what you need to do is you take the empty weight of the container. Empty weight of container. Empty weight of container, I can read this one as a W1. W1, usually we will consider mass only, therefore I will consider M1. M1 is what? Empty weight of container. Okay, na? Then after that I will put this soil now. Then I will measure this weight. I will measure this mass. Then I will write it as container plus wet soil. Correct? Initially the soil will be wet. Therefore container plus wet soil, I will read it as a M2. Right? And these three containers I will put in the oven. Which oven? Thermostatic oven. When I put this thermostatic oven, there I need to maintain some temperature. Some standard temperature I need to maintain. The temperature maintained is 110 degree plus or minus 5 degree centigrade. This much only we need to maintain. Sir, why this much? Why not less than 110 degree plus or minus? See, water boiling point is 100 degree. And if you increase the temperature more than 100 degree, then water can evaporate. If you decrease the temperature less than 100, if you keep, then water will not evaporate. One point. Therefore, we need to take always more than 100. Then your next question might be like, sir, what happens if I take 200 degrees centigrade and determine the water content? When you increase the water temperature more than 120 degrees, say 120 degree and all, then inside the soil some properties, some textural property, some structural property, they will be collapsed. Soil will lose its strength. Will lose its strength. Therefore, we should not disturb the soil's its own property, and we should only evaporate the water. Therefore, we have to maintain 110 degree plus or minus 5 degrees centigrade. Okay, na? Then after that, this 3 containers we need to put in the oven for 24 hours. Then why 24 hours? The reason behind is just a simple, to have a well convenience. That today if you put it 9 o'clock, then tomorrow 9 o'clock you come and open it. That is a convenience. That is 24 hours we are going to put in the oven. Then after, when you put these in the oven, after 24 hours when you come back, then this will be evaporated, no? This water will be evaporated and you will see only dry soil. Then you measure it. In the fourth step, you will measure what? Container plus dry soil. Container plus dry soil, you will measure and you will call that as a M3. Okay, now you come to know that M1, you got it M2 and you got M3. These M1, M2, M3, by using these you can calculate water content. Okay, now next it is said, what is the formula? Is there any blank slide? Yes. Is there any formula? Yes. Formula is very simple. That is the basic definition, says what? Mass of water to the mass of solids. Okay. Mass of solids, mass of water means what? See here, this is the wet soil and water is evaporated. That we cannot catch this one. We cannot catch this evaporated water. Therefore, initially we had a wet soil and after that it become a dry soil. Means in this process the water is evaporated. If I take the difference between the wet soil and the dry soil, then I will get the water evaporated. Therefore, this is mass M2 minus M3. M2 is a mass of wet soil plus container, M3 is a mass of dry soil plus container, divided by dry soil. Dry soil is in the third container, that is a M3, but container weight I don't want, therefore M1. And into 100 if I do, then I will get a water content over. Okay, now the tabular column is what? First you write it here, that is a empty weight of the container, call W1 or M1. Then second tabular column is empty weight of the container plus wet soil, call it as a M2. Third one is empty weight of the container plus dry soil, call this M3. Then fourth column is water content. M1, M2, M3 use, and this equation you use and you will get here. Fifth one is average water content, because 3 containers you are using, no? Average water content. Then you make a column like this. This is the first trial, second trial, third trial. Then you do 3 trials for this and you will come to know. Right? This is the water content. Hope you understood. And the second thing is that water content by Pythonometer method. That Pythonometer means, you might have seen this Pythonometer. I will show. This is a Pythonometer. In BMT lab also you might have seen this one. This is a Pythonometer. By using Pythonometer also we can determine water content. Okay, na? This method may be used when specific gravity of the solid is known. When you know specific gravity of the solid, then only this method can be used. You can put it in the demerits also. This is the relatively quick method and considerably considered suitable for coarse grained soils, not fine grained soils. Fine grained soils, this method gives a wrong result. Therefore, for coarse grained soils means what? Sands, and for gravels, this method is a very good method. Okay, now what this method contains is, first you need to take a empty, dry, cleaned pythnometer, and after that measure that one, that you call it the W1, and after that in that empty, dry, cleaned pythnometer put the wet soil. See, it's not meaning that you are putting solids and water above that one. No, not like that. This is a wet soil only. For your study purpose, the solids are separated and kept at bottom, and water is separated and kept at the top. It doesn't mean that they are separately kept. Okay, now then in the second step you will get a W2. W2 is a pythnometer plus wet soil. And in the third step, what you need to do, you need to pour lot amount of water, and after that you need to till it covers, till it fulfills that lot amount of water you need to put, and after that you need to measure that weight, that is your W3. And after that you need to empty everything, each and everything empty, and clean it again you fill a full amount of water into the pythnometer, that you call it as a W3. Okay, now by doing this one, how we will get that water content? For that we need to derive an expression. Now look at here, I want to express this W3. I want to express this W3 in terms of W4 and W2. How can I express? See here, W3 equal to, come back. See, W3, what is there here? This solids is there here. This solids I need to remove the solids, and in the place of solids you put some amount of water, then you will get this diagram, correct? Remove the solids and put that place water, then you will get this diagram. Therefore we'll write like this. W4 equal to, in the W3 diagram you remove mass of solids and you put water, mass of water. But mass of water, how much you need to put? How much you need to put means the volume, how much you remove this solid, that much volume you need to put. Therefore, I need to get Vs into gamma W. Gamma W is the density of water. Vs is what? That is the volume of solids. This how I got? This is a gamma W. This gamma equal to weight by volume, right? Then weight of water I want, and this weight of actually water, then this is the water. But in the place of solids I need to put the water, therefore Vs I will write here and I will put this one. Understood? Now this W3 let it be here, W4, then bring this W3 this side, then this side, this is a minus, and Ws is a Ws. This what I can read is, see here, specific gravity is the gamma s by gamma W, na? Then G, specific gravity is the ms by Vs, na? Density of solids ms by Vs into gamma W, na? Then Vs into gamma W is what? Vs into gamma W is ms by G, but ms are here I am measuring in terms of W, therefore it is a Ws by G. I got it, Ws by G. Right? Now this is a W4 minus W3 equal to, I will interchange this one so that this minus will come inside. Therefore Ws is taken common, 1 by G minus G1. Correct? 1 by G minus 1 I got. Now I will get here the expression Ws equal to W4 minus W3 divided by, this is okay, and this one I need to take that side. First I will LCM, this is here only, then I will take that, and this becomes G divided by G minus 1. 1 minus G. Okay, this become 1 minus G. Then here 1 minus G is it doesn't look good because 1 is smaller and G is always more than 1. It doesn't look good. Therefore, I will interchange this one. And here also it doesn't look good because M4 is smaller number, M3 is a greater number. Therefore, interchange this, you will not get any difficulty and mathematical errors. Therefore, W3 minus W4, G minus G by G minus 1. This is your Ws. Okay, now go to the figure. Then what is the mass of water here? Then this mass of the water can be measured like a this is like a W2 minus W1 minus Ws. In this diagram, container you remove and you remove the solids, then you will get a mass of water. Therefore I will write here weight of water equal to total M2 is W2 is there, from that you remove Ws, from that you remove container weight. Okay, now I will write it as somewhat in a good manner, that is W2 minus W1 minus Ws. Okay, now I can put it bracket here, no problem. This is mass of water. Then what is the water content definition? What is the water content definition? Water content definition is weight of water to the weight of solids. Now what is weight of water? Weight of water is W2 minus W1 minus Ws. What is the weight of solids? Weight of solids is Ws. Then again, if I split this one, W2 minus W1 by Ws minus 1. Then what is this Ws? W2 minus W1 as it is. What is this Ws? Is here. That is your W3 minus W4 G by G minus 1. Wait. This will come to the top and this will come to the bottom. Therefore, G minus 1 by G it is. Okay. Therefore, G minus 1 by G minus 1. Therefore, this is a water content. Okay, now by performing this experiment W1, W2, W3, W4, you can determine water content. This is the instant method, because oven dry method is a time consuming method. Why? Because there you need to wait for 24 hours. Here within a 1 hour, 2 hour you can get the answer. But Indian standard will not recommend this. Indian standard recommends only oven dry method because that is a standard method. Right? Now coming to the determination of specific gravity. The definition of specific gravity is already learned in the first module 1A in the previous sections. But here just I need to show you how to determine specific gravity in the laboratory. You already know in the BMT lab and in many labs you will come to know. You will be doing this experiment. See, the procedure is very simple. The procedure says that you take a this one, what, pythnometer, make it empty, dry and clean, measure that as a W1. Then after that put oven dry soil. This is very important. This is oven dry soil you need to put inside. How much? Just a rough estimation. This is the 1/3 of height. This is a rough. It's not like you need to go and measure 1/3, and just you put a 1/3 of soil here and measure that as a W2. And after that put a lot amount of water, stir it well. Very important is what? Stir it well, because all the voids present in the soil should come out and that void should occupy water. Therefore you need to stir it for 10 minutes. Take a glass rod and stir it for 10 minutes. Okay, when all the voids are removed and all the voids are filled by water, then you measure it W3. After this, then go and empty this soil, this mud. It become mud, no, mud and water, everything, empty it, clean it again, wipe it again, and after that put a full of water, only water, pure water. Then measure this as a W4. After this, I need to derive an expression how I can get a specific gravity from this. Right? Specific gravity can be got by this. See, again I will express this W4 in terms of W3 and this one. See how I can get full of water here means solids you remove it and in the place of solids you put the what? Solids, water. remove the solids and put the water means you got this diagram. That mathematically I can say that W4 can be achieved like in the W3 I will remove what? Mass of solids and I will put how much void solids are there, that much amount of water. See what I am writing, I am synchronizing with the statement. Okay, therefore you will never get the confusion. See, W4 can be expressed as from the W3 I will remove weight of solids and I will add this much of water. See, this much of water. Okay, now then after this just a rearrangement, mathematics. Okay, now in the mathematics in previous lectures I got in previous water content you come to know that G equal to gamma S by gamma W, and gamma S means what? MS by VS, and gamma W as it is. Then gamma S VS gamma W take this side and G comes this side, therefore this you can write W, and here this becomes W3 minus WS plus WS by G SG, then this is your W4. Now what you need to do, G is there here, G is there here, and which is unknown, concentrate here, that's it, over. Now what I do, I will take this W3 this side, I will take this here W3 this side, means this minus will become somewhat it doesn't look good, therefore what I do, I will take this entire thing that side and W4 this side, correct? Then this WS that side WS, and this WS by G that side WS by G equal to W3 minus W4. From this equation WS take common, WS taken common, 1 minus 1 by G equal to W3 minus W4. Do not take LCM and mix it, okay, keep it like that only, that is good. Now 1 minus 1 by G equal to W3 minus W4 divided by WS. Now this 1 minus G take this side and this entire equation that side. What happens? 1 minus W3 minus W4 by WS equal to 1 by G. Keep it like this only. Here we will take LCM. WS minus W3 minus W4 divided by WS equal to 1 by G. Now reverse both side, then you will get a G equal to WS minus W3 minus W4 divided by WS. Okay, come back. What is WS? This is WS. How I can get a WS? WS can be get as W2 minus W1. This is W1. Therefore W2 minus W1 minus W3 minus W4 divided by W2 minus W1, that is your G. Parlay G. Right? This is a specific gravity. Now I included two photo here. This is a pycnometer, this is a density bottle. Why these two are there? See, when you perform specific gravity test for coarse soil means either it is a sand or it is a gravel. When you perform a test for coarse soil, use pycnometer because large quantity is suggested by the Indian standard, therefore it is good one. When you perform a specific gravity for fine soil means clay soil or silt soil. The particle sizes are very small, therefore you use a density bottle. This is called as a density bottle, and the procedure is same. W1, W2, W3, W4. If you use this also, W1, W2, W3, W4. And if you perform this is complete. Thank you very much. And in the next class, we'll go to the third index property. In this class, we completed first index property, water content and its determination. Second index property, specific gravity and its determination. Right? Thank you.